Okay, here is section 3-3, equations in y equals mx plus b form. Remember, m is going to stand for slope. Make sure you get page 190, the key concept in notes. It's about direct variation. Basically, it talks about how when y varies directly with x, then we can put it in the format of y equals mx, where this is the slope. If we have a y-intercept, then we will put it in the format y equals mx plus b. In other words, in this situation, where we have a line going right through the origin, the y-intercept is 0, so this would be plus 0, so we just write it in this format. If we have a line going through here, and let's say this was 6 on the y-axis, then we would say y equals mx plus b, where b would equal 6 in this particular case. You'll learn lots more about that later. This is what you need to know for now. Example number 1. So the question is how much per hour in the problem. So we have the money earned on the y-axis, vertical axis. On the horizontal axis, the axis, we have the time in hours. So some of these it's not real easy to see exactly, but they do talk about the points of 2 and 15. So if you look at 2, and you can see in the book that it goes through 15, and 3 and 22 and a half, you would probably not be able to read it to 22 and a half, but 4 and 30, and 2 and 15 are pretty easily read. So the way they did it is they said, let's look for the constant of variation. It would be 15 over 2, 22 and a half over 3, and 30 over 4. And if you put all of these in the calculator, they all come out to 7.5 over 1. Okay? Another way to do it would be to look at this as a slope problem, where you could look at the rise and the run, the rise of 15 and a run of 2, or from this point to this point, the rise of 15 and a run of 2. So we have 7.5 either way. This refers back to the very first thing we talked about when we talked about this lesson, where we talk about how we can look at constant of variation or direct variation or slope or unit rate as all kind of different ways of saying basically the same thing. So we find the constant of variation is 7.5 over 1, and it's $7.5 over 1 hour in a unit rate. So it's $7.50 per hour. Another way we could do it is look at it as slope is rise of $7.50 and a run of, a rise of $15 and a run of 2. We can simplify that to 7.5 over 1, or $7.50 per hour. Please press pause and do letter A. Example number 2. In this case, we travel 3 miles in 25 hundredths of an hour, or in other words, 1/4 of an hour. And they want to know how many miles per hour can we travel. So we can make an equation. They also say the equation y equals 12x. So we can make an equation. We have hours here in our x variable, and then we have y equals 12y for our equation. 12x, that's an x there, doesn't show real well. And then miles is y, our output. So think of our input as 0, 1, and 2. Input that into the equation y equals 12x, and we have y equals 12 times 0, and then 12 times 1, and then 12 times 2. Our output then would be our y values. 12 times 0 is 0, 12 times 1 is 12, 12 times 2 is 24. And now we can look at our rate of change on this side. It's plus 1 in each case. Over here it's plus 12. And now it's change in y over change in x. And we get change in y over change in x is 12 over 1, which is of course our slope, which is also the same as a unit rate, which is exactly what they're looking for here. So we have 12 miles per hour. 12 miles per hour. That is exactly where everything comes from in this particular problem. Please press pause and do letter B. Example 3, which animal is faster? So you're looking at this in 2 different ways. In the first case, they give you the rabbit and they give you an equation. So they say D equals 35t. Well, remember, this is in the format of y equals mx plus b. In this case, instead of y, we have d for distance, and it's the slope times the x, which in this case is time, plus the y-intercept, which in this case, this would be like plus 0 here, so we can ignore it. But the thing I want you to understand is the 35 gives you your slope. So m is 35, so we know that the rabbit can travel 35 miles per hour. Okay, just exactly right there from the equation. The grizzly, on the other hand, you have to look at the information they give you, and you can see that the rise is 30 and the run is 1, so 30 over 1. Of course, the slope in that case is 30, excuse me there. So in that case, the slope is 30. So the grizzly bear can travel 30 miles per hour. So we say that the rabbit is faster, 35 miles per hour over 30 miles per hour. Please press pause and do letter C. Example number 4. We have a 3-year-old dog, and we say that in human years, that dog would be 21 in human years. Okay, so we can say that y varies directly with x, y being the human years, and it varies directly with x, which is dog years. So then they ask you, okay, how old in human years would a 6-year-old dog be? So the first thing we need to do is set up an equation where we have y equals mx. So we have y, which is our output, which is 21. 21 equals the slope times 3, the input of x. Divide both sides by 3, and we get 7 equals m. So m is our slope. So now we can use the same formula again, y equals mx. And now we're going to say we're going to have, with a slope of 7, how old would a 6-year-old dog be? So now we have 7 being our slope times our input of x in dog years, which is 6, and we get 42. So our output y in human years would be 42 human years. Okay, here are your solutions to 3-3, the letter problems. First of all, problem A. We are told that the person is descending at 2 minutes. They have descended 1,900 feet, 1,900 feet. 5 minutes, they have descended 4,750 feet. And we're asked, if the distance varies directly with time, what is the rate of descension? How fast is this person falling, basically, is what it amounts to. So we can find the difference here. We have a rise of 3 minutes. Here we have a fall of 2,850 feet. So we can go with the change in y to negative 2,850 over the change in x, which is 3. We can simplify that to negative 950. Now, because it's negative, it is showing that the distance is decreasing, the distance from Earth, in other words. So we have a descending rate of 950 feet per minute. So in other words, this would be like a downward slope if we were to graph this on a coordinate plane. Letter B. In this situation, we have to both fill out the y and the x axes, and they give you the problem. Okay, so we have, first of all, cost would be over here. This would be the cost of the oranges in dollars. This would be the number of oranges through 9, and then we can see that at this point right here is probably the best place to go with, and we can see that 9 oranges cost $9. So the best way to take a look at this would be to use rise over run, the slope, in order to find the unit rate. So the rise is from 0 up to 3, and then the run is from 0 down here. I have to do it both down here and up here, but normally we go up and then over. So then we come across and we have 9. So we have 3 over 9, which is 0.3 repeating. We're just going to carry this to the hundredths place and then put approximately, or about, 33 cents per orange, because remember this was in dollars, so 0.33 would represent 33 cents per orange. Letter C, we have time in hours on the x-axis and pay in dollars on the y-axis. Input, output. Input 15 hours, we get $112.50. Input 12, get 90. Input 22, you get 165. Input 9, you get 67.5. They tell us that this is a direct variation, so we know we don't have to put this in order and check and make sure that the difference between each set is the same, or that it's constant, because it's a direct variation. We know that to be true, so we can just pick one. I chose this one. So if we went 90 over 12, 90 divided by 12 is 7.5, so it's $7.50 per hour. So the question was, if this is what he currently makes at his current job, should he take a job making $7.35 per hour? So we would of course say, no, keep your current job, because $7.50 per hour is better than $7.35 per hour. Letter D, 210 miles in 3.5 hours. Again, we're told it's directly proportional, so if we do 210 miles in 3.5 hours, our unit rate would be 210 divided by 3.5, or 60 miles per hour, because it's miles per hour, okay? And then they told you to write and then solve a direct variation equation to find out how many miles, I should say, in 6 hours. So we have y equals 60x, because our slope goes right here in the y equals mx plus b form. There is plus 0 here. It doesn't really, we don't show it. Okay, so if we put y equals 60x, if we put in 60 hours, hours would be for the x, so y equals 60 times 6, and that would be 360 miles. In 6 hours, we would travel 360 miles, right here. Letter E, we have a butterfly that does 93 miles in 15 hours. We're told that this is another directly proportional situation. They want you to write a direct variation for 24 hours. So first we say 93 miles in 15 hours is 93 divided by 15. That gives us 6.2 miles per hour. Feed that into our equation, which would be y equals slope of 6.2, our unit rate, times x. Well, the input of x is going to be 24 hours, so y equals 6.2 times the input of 24 hours. That means we could do 148.8 miles in that 24 hours. I shouldn't say we, I should say the butterfly can travel that far. Almost 150 miles in a day. Please do guided practice.